I'm the Executive Director of the Sustainability Management Association, and I'm going to mute a few of our callers just for a moment. There we go. So excuse me, my name is Angela Kassler. I'm the Executive Director of the Sustainability Management Association, and we welcome you to our webinar series called Transforming Leadership. And we're an organization that we'd really be honored if you would follow us on social media. Here's some of our handles for you, and my direct email if you'd like to get in contact with me after the call as well. And I just wanted to give you a quick introduction to the SMA so that you may be able to be familiar with who we are and what we do. We're truly a group of individuals who are interested in managing for sustainability and believe that leadership in all organizations can put sustainability into strategy. And our purpose is really to help with education and creating widespread knowledge, skills, and abilities on how to manage sustainability in any type of organization. And we offer 3 services. One is membership is open to anyone who's interested in sustainability. And we also, our main services, we offer a certification, which we are the accrediting body for the certification called Sustainability Management Certified Professional for those people who are working in sustainable fields with 2 or more years of experience. And the SMCA, the Certified Associate Certification, is for people who are learning about sustainability. We also issue continuing education credits for all of your certifications that you may already have, and we do offer a 1 credit hour for attending these webinars. So please do reach out to me via email if you would like me to send you a CEU today, and we'd be happy to help you with continuing your education. A little bit about the certification. The body of knowledge that's in the study guide is really starting with strategic management and including sustainability as one of your top priorities, and then how to speak the language of sustainability and look at the programs that you would be developing to develop metrics for KPIs, and also how to measure those outcomes and be able to report those internally to your own staff and externally throughout your own value chain. The study guide also goes over external ways that we can collaborate with our supply chain to be able to create the solutions that we need that we can't create on our own as an organization that may have to do with packaging or recycling or product development or product content. And so we're very proud of the study guide and the people that are certified with us. And if you'd like to get more information or learn more, you can reach out to me directly. My email is akassler@sustainabilityma.org, or you can go through our website and take a peek at what we have to offer. We do have a third-party trainer called the Center for Sustainability Excellence out of Chicago, Illinois, and they do all of our training for the certification, and many people decide to study self-study and have passed the exam as well. And we'd certainly enjoy inviting you to be a member of the organization and to give you some more information about the study guide for the certification. This was written in the purpose of teaching people how to manage for sustainability, because we kind of work in silos, whether we're water experts or air experts or energy experts or CSR experts. And this study guide, we tried to roll it all into one to say all of these fields are very important in the realm of sustainability, in which we deem to manage for triple bottom line for both social responsibility and environmental management, as well as financial performance. And so many of our members are top innovators in our fields of sustainability, really doing important work in pioneering how we're able to accomplish many changes that we need. And I welcome many of our board members to the call today. Thank you so much for joining us. I did see Michelle Vicentin and Jim Wagner on the call today, and Kevin Cochran. And Rex Hayes is our speaker, and he's a brand new board member. He is the CEO of Climate Inc., and we're excited that he's able to do this call for us today. We hope that you truly feel that sustainability is also about being transformative and how we can take leadership to the next level to really lead our organizations for tomorrow instead of just today. And we are welcoming all of our members from across the country. We have achieved 28 states here and 12 different countries around the world, and we're super proud of all of our members who are managing for sustainability. So throughout the call, we'd like you to be able to chat with us about your interest in water and anything compelling you hear on the webinar, any comments that you'd like to offer to Rex Hayes, and questions, because during the call you're welcome to ask questions as well, and also to chat those to Rex directly. And in the meantime, what you can also do is he'll be asking us questions, so please make sure to unmute yourself and then afterwards to remute yourself if you can. And I'd like to introduce you to Rex Hayes now. He is the CEO President of Climate Incorporation. And Rex, I'm going to go ahead and change the controls over to you so that we can see your PowerPoint deck now. And Rex, I'm sorry, let me go ahead and unmute you as well. Just a moment. Okay, Rex Hayes, can you hear me? Let's do a quick test. Yes, I can. Thank you. Sorry, I had to unmute you.
That's okay. So that toolbar doesn't bother everybody. I'll just leave it there. It doesn't make a difference. But hey, thanks for having me today. I want to take everybody through a little rainwater harvesting 101. Some of you guys on the call actually know me personally. Some of you I've worked with over the years that I've been doing this. But a little bit about rainwater harvesting and its benefits. You know, a lot of people look at this and, you know, I would be remiss if I didn't talk about it from its very beginning. So rainwater harvesting's been around for over 2,000 years. I've had the blessings of seeing some of the oldest rainwater harvesting systems in the world, around the world. And as I get a chance to look at those, it's so reminiscent that be able to look at something that's been around for 2,000 years and know that people have to have it, not necessarily they want to have it. But getting to the sustainability part of it, as Angela spoke about, and what SMA does is really help educate people. And educating you on rainwater is hopefully where we start that ability level today, take you through some steps of rainwater collection, residential, commercial, industrial projects, look at those cutting edge technologies that are out there, and starting to look at some of the reclamation strategies that are involved in the process today. So as we become better stewards of our water around the globe, we start to become that zero water user. So as you can see, primarily on the two slides on the right, the pictures, this is a very unusual circumstance because, like I said, you know, in the U.S. and a lot of complex nations around the world, we take for granted that water is a process that we have every day to our regular use. You know, 72.9% of the Earth's surface is covered in water. Out of that, a little less than 2% is actually potable to a human. So there's a lot of factors that start to go into that, and that global water level, overpopulation, increased acquisition and development of land, those are all key factors. But one of the bigger factors that people really don't understand much is the deforestation. And through that, it causes regional and unprecedented areas to be critically affected by unusable water. One would be for something we see every day, but people don't realize that grounded water doesn't percolate in these deforestation areas. It runs off, creating it as grounded water that's contaminated with pollutants, nitrogens, phosphates, all kinds of things that come through fertilizers, not just what comes off of the streets and off the parking garages. That's one effect that is a critical contaminant, but more so around the globe, it's really from deforestation and not letting the water percolate. So keep in mind that all those streets and infrastructure have a lot to do with it. Just allowing the opportunity to naturally progress back into the aquifer is a big deal. One of the questions I always get asked is, you know, when people look at it and say, well, but if you're going to collect rainwater, then you're not letting the water percolate back into the ground. Although that would be true to some effect, it's such a small percentage, because the overall aesthetic that you really want to talk to people about is because of the infrastructure with roofs, roads, parking garages, malls, large utilities, things that would change it, would change the grounded surface. Instead of being able to percolate, it becomes insaturable with water. Well, that water runs off, creating the stormwater like we talked about. But more so, collecting rainwater slows that position down. And by the way, by building, it allows us to be able to use our water more practically. And we'll go through some of those steps here in a second. So really the truth about rainwater is the strategy to maximize the natural resource. You know, trying to minimize our environmental impact as much as possible, but the urban water that's there today is more critical than you see in rural areas simply because of the massive infrastructure changes. So as you can see in the top slide, not that it would be something that would not necessarily be seen a lot, but you're going to see a lot more of it in the near future, especially in the U.S. Popeyes, in this particular case, is using rainwater, and on their property, all of their irrigation on this particular property is done through this irrigation tank that just holds rainwater. Comes off the building, doesn't go down, and by the way, this Popeyes is sitting 1,000 yards from the ocean. So it allows none of those extra runoffs from anything from a herbicide, pesticides, pollutants from the parking lot to enter into the stormwater management as possible. Down on the bottom, you'll see more of the factors such as climate change happening, overpopulation has happened, especially, you know, so much more towards India. Some of the more rural areas are becoming more urban areas in places like Brazil, South Africa, obviously in some of the densification processes here in the United States, throughout Mexico. So multi-story residences and complexes have started to construct that at a rapid speed. And what I mean by rapid is, think about water that could naturally percolate by hitting the ground, puddle, and then saturate into the ground, versus hitting the top of a multi-story building, let's just say 30 stories, and by the time it actually comes down the effluency pipes inside the building, it's running at a very rapid speed. So when we can collect rainwater in those particular scenarios, or stormwater before it really goes into the aquifers, and reuse it on the same environment, it's a lot more conducive. So let me tell you a little bit about some of the knowledge that comes up from it. When you look at the European Union and you look at countries specifically where rainwater has become a very natural everyday process, we could talk about Germany. Economics, centralization, governmenting, everything's very similar to the U.S. And the reason why I bring up Germany is, since 1989, it's been the law in Germany that if water hits your area, meaning the land that you own, you actually have to either allow it to percolate slowly back into the natural environment, or you have to reuse it on your property. That again it's a federal mandate, which we don't have in the U.S., but for so that you're going to see a lot more of those, and going to be in municipalities around the country. As Angela spoke about earlier, for some of you guys heard her, she lives in a part of the country which for 5 years had had an extensive drought, and now they're having tremendous flooding and runoff, which has created, you know, a catastrophic event, earth-changing at best, but worse off, the naturalization of the property and the lifestyles that people are used to. I live in the southeastern part of the country, and for about 6.5 years, we had a really nasty drought. So when you look at things like rainwater management, you can start to look at, it's a very underutilized process, especially when you look at the non-drinking factors of it. So the non-drinking factors would be more specific towards, it eliminates flooding, or it decreases it significantly. It decreases a lot of groundwater runoff into the stormwater that has to be treated. That in lieu creates a little bit more or less of a strain on our drainage system, but less of a strain on the drainage structure infrastructure changes as we go through. So the groundwater levels and recharging it really aids to enhancing that property. Whether you go to the far left-hand corner of our presentation, which would show you a very old farm with a rainwater management process, and it actually backfills with potable water directly out of an aquifer. today in that particular property, that's not allowed in that particular city any longer because the aquifer is not being able to be recharged as fast. On the right-hand side, you're going to see a photograph of 3 very large above-ground cisterns that in the parking garage that's in the background of it, it actually takes almost all of the rainwater that would not be allowed to be able to percolate. Instead of allowing it to be stormwater and have to be treated in the urban environment, it's stored and it's going to be used on the property. A lot of it's going to be used for irrigation, and some of it's going to be used in adjacent buildings for toilet flushing. So there's a lot of variations to be able to go through this, and we're going to take you on some of those journeys in a second. So one of the things I've always been asked about rainwater harvesting are, what do I need to do rainwater harvesting really well? Now, obviously, if you were just going to use it for irrigation, a lot of people would just catch water, and then they would just go out and use it for irrigation. I take myself back in years to something we talk a lot about at work, which is the petticoat junction tank, which is just an open tank. You dip a water bucket in there, and you go about your business. Well, today, there's so many pesticides, herbicides, and other chemicals that are in the air that having something exposed really is really not a forgiven type of event. So what we talk about is rain harvesting system components, having the right pre-filter. Well, that's important to have the right pre-filter, that if you're going to have a tank, you want it to last a long time. The pre-filter breaks things down, leaves, debris, things that would be flying in the air or hitting the substrate, whether it be the top of the building or top of the house, and it really washes that debris away. And today, these types of filters are very, very efficient in what they do. So they don't lose a lot of water, but they flush a lot of that big debris away. As it enters into it, you'll see on the PowerPoint, number 2 is the common inlet. What is that? Well, a lot of people really don't understand that part of it. A system always going to have some level of debris that gets in the tank. Once it hits the bottom of the tank and settles, it creates an actual anaerobic material that's very good for the water. It's almost like a live bacteria, if you would. And what it does, if it's not constantly turned up, is it makes that layer on the bottom of a tank or a cistern. And again, anything that gets in there, it continues to just kind of dilute it down and break it down through the water cycle itself. Then number 3 would be if the water starts to get high and you might have some pollen and things like that in there, the overflow siphon allows you to start to skim off that extra debris naturally out of the tank and also keep the tank from being able to overflow. So it's got a 2-stage system. It actually siphons and it actually cleans off debris off the top of the water. And then number 4, which in this particular illustration is a floating extractor, and that is usually taken down below 500 microns, and the water that comes through there, it floats beneath the surface but above the bottom, and it takes the cleanest water out of the tank all the time. That part of the tank is usually almost debris-free if you were looking at it underneath of a microscope. So that gives you the opportunity to really get the best optimal water level out of the tank all the time. Our next slide is going to kind of break that down. And again, Angela's going to make this all available to anybody on the call so you guys can have this presentation available. If you have questions, by all means, definitely ask. We'll do a little chat at the end. But the debris filters you see, that's step 1. It's easily cleanable, but generally saying, most of these type of filters are pretty much self-cleaning. We like to tell people, depending on where they live in the world, you might have to clean them out once or twice a year, but they literally have a screen mesh filter, a patented product inside, and it lets water cascade through it. Very, very efficient. Number 2 is that settling common inlet. As you can see, we commonly refer to it as the dog dish. It's very unusual where the pipe will come in through the filter, drop down to the taller part of the common inlet, and as you can see in the inside of it, it actually splashes up against the inside and slows the velocity of the water into the tank, not stirring up that anaerobic layer. So as it does it all the time, it constantly gives you oxygen in the water as it's splashing inside of the tank, and it gives you the ability to oxygenate the water. And anybody knows anything about water, the more oxygen, the cleaner and purer it's going to be. floating filter hose and the overflow siphon. They're a little different in this picture, so you can see them a little bit easier. But again, you can see the floating extractor in the ball. The ball can be used in two different manners. A lot of times people will just let it float in the tank, especially if they have it on a shorter hose. So the actual ball will actually never be able to touch the bottom of the tank, even if the tank were empty. So the extractor wouldn't even lay on the ground. It would still lay up off the floor. Or two, you can tie a tether onto the top of it, and you make it so it always floats at a certain level in the tank. That way it's going to maintain a certain type of environment. Both, as you do water testing on a tank, both work well. The biggest ability is to make sure you use a common inlet so you don't have any extra debris that's floating around there from the anaerobic stir. And in that protection overflow, or what some people call a siphon overflow, the pipe that's showing you to the left-hand side of it literally sticks outside of the tank, and that's where you connect on your drain pipe. And as the water level gets too high, it overflows. On the right-hand side, you can see it's kind of cut off at about a 45-degree angle. That's so it skims water as it comes closer, and it can take debris off of it. So there's a lot of things that go into this type of technology. But again, it's a far cry from what we saw, the original ones where water really goes into a concreted cistern that's not even protected, even with a paintable surface. These are just going to give you some quick overviews of what tanks look like, kind of give you a snapshot of something that's in the industry today. This is a regular, what we call a steel galvanized tank. Some people refer to them as grain tanks. They basically have liners inside of them. And they can be made into all kinds of liquid storage, rain tanks. You can keep other types of chemicals or corrosives in them. You can keep oil in them. You can keep pretty much anything inside there as long as you've got a license for it. As you can see on this particular one, it's just a clean looking tank, and they last between 20 and 30 years typically in the weather with very little maintenance to them. This system right here is about 2,200 gallons. Easy off of a nice roof, clean. Here's another look of another tank. It's about a 5,000 gallon tank. Again, it's a very easy installation. It's on an office, very clean, very sleek, very easy to work on, very low maintenance long term. And like I said, a tank like this typically will last between 20 and 30 years, as long as it's looked at by a certified technician on a yearly basis. Well, let's get more into the commercial and residential, because I think that's where the body of our people are phone call from. So commercial and residential, the biggest thing I want to talk about here is making sure you take the precautions to have locking lids. Oftentimes, I have children. I'm sure that most people on the call do, and people like to climb on stuff, especially something that looks like it's a play toy. So you want to keep the lid locked, obviously, because you have some situations with liability, and obviously someone can get hurt. But the biggest thing about it is not so much that, it's the breeding of mosquitoes and insects in the stored water. When this lid is closed, as the picture shows on the far right versus the far left, that tank literally will take in water, and it can stay in there almost indefinitely. The light kept out of it keeps algae from growing in the tank, keeps it from having to be treated. It also, with the tank being closed, it has very little insects in there. So why do people use these? You can see on there a lot of non-drinking purposes, which would be irrigation, car washing, laundry, toilet flushing. These are everyday common practices. You'll see from the middle slide, the middle picture in the slide, this is an atypical scenario where a school will send us a blueprint and say, hey, we want to put a rain tank on, and we kind of want to do some stuff. And one of the reasons why is because they want their LEED certification. Most of the time, I would tell you, my sales directors and I always have conversations, and they say, look at that little tank that's on that blueprint. And it turns out to be something much bigger when they actually know what the practical purposes are. And again, unless we can continue to educate people, and that's a lot about what SMA does, is educate people about the uses. So it will be an essential opportunity for us to work through. These are just some quick snapshots of some different scenarios where these are barrels, what we call rain barrels, and they're very cosmetic. They're very practical. They range anywhere from 75 or 80 gallons up to a couple hundred gallons, and they're very, very easy to install. You can see that on the the two bottom ones, you'll see two pre-filters on the downpipes before they go into them. Again, they're very practical. The one on the top right that looks like a tree, you can see the little line on the top of it. Those lids come off of them, so you can literally stick a full-size watering can inside of one, not just fill it from the downspout. So these are also very practical purposes for homeowners. They're very practical around the office. You know, I like to tell people all the time, you can come over and fill your water up, and you can water all your house plants all you want to. And house plants and your landscape plants love rainwater because it's virtually chemical free and debris free. So it's very, very easy for them to use. So let's talk a little bit more into the depth of technologies. We're back to square one on the left, which this young lady is doing something she has to do every single day, which is hand pump water out of her concrete cistern. These cisterns are built from the ground up on her property, every single facet of it. I actually, this is one of my favorite type of projects to work on around the world, and it brings me back to the net root of what we really do this for, which is helping lower the ecological footprint of the way people use water around the globe. So you can see as she's hand pumping some water, which is a daily effect, versus on the far right, which is an automated pumping station. Today, both are very practical. Both happen every day in this business, and they certainly happen all the way around the world. So one will help some automation. The one on the left is very practical and is absolutely a necessity. So as you look at new technologies, sometimes technologies like the far left, we can bring new like technologies to old world type of opportunity. These cisterns on the left, for instance, are currently underway of being lined with a brand new liner that we manufacture in the industry today that was brought around by new technology. They can be retrofitted, and that liner can keep that cistern from breaking down over the 10 or 15 year pattern to about 25 years for people today. So just think about if you were a resident in the photo on the left, you now are going to get about 10 more years out of your cistern and zero leaching from the ground in through the concrete. So new technologies sometimes still are very simplistic. These are more of the high-end technologies around today. This happens to be a brand. There are lots of them out there. This particular one I happen to be really engaged with. We actually install a lot of them. We talk to a lot of clients about them. Very popular product. And what it does is it takes in through the cartridges. Let's just talk about that bottom left. Takes into that first cartridge, and that's just taking in some extra sediment, breaking sediment down to about 10 microns. What's a micron, people ask me. 2 microns is about the thickness of a human hair. So about 5 times the thickness of a human hair particles are inside of that first sediment filter. It'll go to the second one, which is usually a carbon block, and that carbon block usually gets it down between 3 and 4, sometimes 2 microns. And then what's left in there could be live bacteria that does exist. It will eradicate inside of the UV bulb. And the coolest thing about this new technology, one, it uses very little electricity. 2, which is an awesome opportunity, it was switched about 8 years ago, and it's an on-demand system. So if water's not actually flowing through it, the UV bulb is actually not burning. So it's about as efficient as you could get. These range anywhere from the low 6 or 7 GPMs for a house, clear up into the thousands for large corporate businesses and multi-city dwelling complexes. So it's a great product. This will show you a little bit more of what the professional series looks like. The professional series really has a longer lifespan. The bulbs last longer. The little meter that you see on the front of the little black box that says Vaqua on there, it actually is a countdown calendar that when you plug it in and it becomes activated, it tells you to the day of when that bulb should be replaced by manufacturer specification. So it's constantly monitoring the system. This system's a little bit bigger. As you can see inside of the silver tube, that's where the UV bulb is. very safe product, and works extremely well. Reason why I bring this up is because this is not necessarily new technology. It's new to this century, but it's not new. Its newness is it's become very affordable on the market today to add to your rainwater system. And the reason why I say this is because a lot of times we often have conversations with clients and people will say, well, how much rainwater storage should I have? And the ultimate answer is no matter how much you have, you're always going to want more, which is a really cool thing. So you always want to be able to size your UV system for all practical uses, not just the uses that someone would have originally. And again, these cartridges on this side are basically the same, except they're larger, so they take in more volume because they need to have more volume through the bulb. Just make sure that the gallons per minute, the GPMs, are actually kept up. As you get more water inside of it too, it gives you the ability to have more of the filtration square surface area inside to attack more of the water quicker. So not only does the filter become more efficient, it lasts a little bit longer. Again, you always want to check with your manufacturer to find out what the specifications and recommendations are, but these filters are basically meant to last no more than 90 days, and the bulb's usually around a year. So that's a practical application for most people. Some of the other new technology that's out there, wow, instead of having a concrete tank under the ground, now they call FRP, which is fiber reinforced product. Most people commonly refer to it as fiberglass, although some are not fiberglass, some are metal. There are other plastics that are out there as well. And you can see, starting on the left, kind of what that symbolically looks like through that schematic of what a tank looks like under the ground. That might be at a local school, might be at a local office. It can be used for stormwater collection. It can be typically used for fire suppression tanks, irrigation, potable water, which is drinking water. They're very corrosion resistant. They can be made into NFS standards for potable water, which is NFS 61. There's all kinds of things that you can use these for, but they are customizable and you can use them for a lot of applications. So building on your left kind of shows you the rendering. Building in the middle actually shows you the practical application. And then the one on the left, I put that in there so you can see, why is that in there? Well, a tank like this, once it's buried, it has to be kept from ballasting, which means kept from floating up, kind of like a submarine. So you got to anchor to the ground. So there's a lot of technical things that go into it. And again, this is a very professional, very certifiable type of job of installation that people conduct. But it is a big part of rainwater management. As I mentioned in Germany earlier, most people in the European Union, which would be Western Europe and a little bit of parts of Eastern Europe, it's the law that they have to collect their water so they don't have stormwater aquifers like we do. And what it does is it allows them to do that, but they don't have a lot of land space. So oftentimes, they're either their sidewalks, their playgrounds, their driveways, sometimes even their garages are built over the top of these tanks for long-term usage. So it kind of gives you the benefit of kind of seeing some insulation differences. Again, here's another type of containment vessel. For water, typically, a lot of people like to put these for irrigation. You'll see these rainwater pillows, especially a lot in South America, being used for irrigation purposes, where you may not be able to either have a confined space that you can get a regular conventional tank into, or in our practical purposes, the last several that we've had that we've built for clients have been in places that you literally couldn't get the other materials into. So these were actually brought in, either hand carried or brought in by animals. So as you can see, a typical crawl space installation on your right-hand side, you see a lot of this in parts of the country that don't have full basements, that they want to be able to use it, or under decks. See a lot of these in the North Texas hill country where people will put it under their deck to keep it out of the light. But know that these flexible storage vessels are very practical. We were having a conversation a couple of days ago with one of our newer dealers, and we told them, I said, you know, one of the biggest things that you'll see from this, excuse me, Sorry, guys. But anyway, these storage bladders are used a lot by the United States military. So they can be made out of material that, one, out in the desert areas can have fuel in them, can have potable water in them. People practically use them today for a lot of stormwater usage and groundwater usage on islands. The island of Bermuda uses quite a few of them. A lot of them are used throughout the Caribbean islands, and they're becoming more and more in the South Pacific islands because they're easy to put in. They're very practical, and for the better content, they're pretty durable outside. So if you can keep it in a pretty nice little area, it works really well for you. So as we go through, the next part of it is kind of a better look at what liners and stuff look like. Why do we show you this? Well, the picture on the top right, for instance, that is an opportunity where the cistern is built underground, then there's a lid put on top of it, and then it's retrofitted. So in this particular case, there's actually a soccer field on top of this cistern. It's closed off at the very end, and then the application is that it fills up with rainwater, and it's reused for irrigation totally. The bottom will show you a little bit different situation where that cistern's inside of a building in the basement, and it was built in a concrete basement. It's put a potable water liner in there, and in that particular case, through UV, the water's taken back out and used throughout the entire facility, which is a fairly large recreational area around a resort. So there's a lot of practical applications and vessels that can be used in using the natural rainfall of rainwater. So how do we take this transition to zero water? I think the big things that we would want to talk about is water is becoming noticeably scarcer, and it's more scattered. So as we look at those type of things, a lot of it could be instituted from climate changes. A lot of it could be because of things that change from an infrastructure standpoint. Certainly as you start to change the wind effects and the way that cold fronts and warm fronts collide because of urbanization and massive skyscrapers, all those things really create a lot of different opportunities. And I would certainly tell you, I'm not a hydrologist, and I'm certainly not a meteorologist, but I can tell you when I look at possibilities like this, one of the things that stands true to me is we are inevitably going to change. So let's look at the technology, let's look at some of the practices that have worked for centuries and continue to work on those so we don't have as many bottlenecks in the process. One would be collecting rainwater. You can use it in a pit, you can use it in a tank, you can use it in an underground cistern, you can use it in a rain barrel. But one of the things is, plants and animals like filtered water. Filtered water meaning that's filtered by the good Lord, not necessarily what's filtered through a canister. And rainwater is a perfect illustration. It doesn't matter whether it comes off of a roof, it comes off of a parking lot, it comes off of a piece of metal or plastic. What it does, though, is when you get it, what do you do with it? The number one resource for rainwater in the United States today is still irrigation. I would tell you rapidly, you're seeing some other things change. If you look up on the right-hand side of this chart, you'll see, what do we look at it from home? Well, at home, a lot of people still use it for irrigation, laundry, showers, and toilets. And you say laundry and showers. Wow. I thought toilets would be more. Well, a typical toilet only flushes at 1.6 gallons. Laundry typically is 25 gallons a load of nothing but domestic water. Shower, 25 to 30. So that's a pretty large amount as you look through that. And one of the opportunities we could do is we could do more hand watering, more drip irrigation. If you look at laundry, showers, and toilets, you can consolidate cycles a little bit more on laundry. Certainly with toilets, I would tell you, is you can educate. You can educate people to understand that today, toilets, although most people aren't realistic about it, you could put in automatic flushing toilets that flush a little bit more regularly. than a toilet valve, especially in a commercial opportunity that leaks. Homes that leak. And inside it just runs water and you don't even notice it until you see your water bill. Offices, you look at somewhat of the same thing, irrigation and toilets, but more so you start to see that influx of stormwater. And what I mean by that is that offices usually have a typical parking lot and a larger roof area where they can use that water for rainwater before it becomes stormwater and reuse it for irrigation and things that directly on the property like they do in the European Union. You know, looking at toilets, especially that have auto cycles. Communities, big opportunity here. Some of you guys do rainwater harvesting for a living that I know that are on the call today. We obviously talk a lot about this as an industry. As a community, how do we do it? We definitely could reuse stormwater before it goes into stormwater sanitation processes. Because once it hits the stormwater sanitation process, it can't be reused legally in the United States at a community level. But one of the bigger issues that we look at in a community is how do we over-irrigate? How many of you guys have been driving down the road and saw someone's sprinkler turned on in a community or in a municipality and it's raining outside? You know, can we educate those people to say, look, you know, we can't do that? And I will tell you, I'm often fond of hearing the conversation with colleagues of mine, especially in Florida, to say, well, the water that I irrigate with is reclamated. Well, it still had to be treated before it was reclamated. So cutting that water use down too, obviously will help the percolation cycle. And then last but not least would be swimming pools. You know, people look at it and educate people around swimming pools. Most people don't know that the biggest user of a swimming pool is not the splashing, it's the person going over and cleaning the pool and backwashing the pool at thousands of gallons a year. And they're just flushing it directly down the storm drain. Cities not much different, but the big thing in cities is look at the parks and recreation areas. In Texas, I will tell you, in California, Arizona, Atlanta, we are looking at a lot of parks and recreational opportunities where we use rainwater to not only educate people, but we're cutting down the stormwater runoff. We're also reusing it on the property for communal gardens. We're looking at it as far as drip irrigation for shrubbery and trees that are plantings. There's all kinds of applications. And certainly not least would be the state. Really, at the state level, I would tell you, most of you guys have probably been in a state office building and you've seen and you walked in and went, wow, this is nice. It's very air conditioned in here. Air conditioning cooling towers, as you'll see on the bottom right of the screen. 1.8 gallons of water are used every hour for every 1 ton of air conditioning in a cooling tower. Usually, in most cases, 365 days out of the year, year over year. Most cooling towers that are in state, local office buildings use between 8 and 18 million gallons of domestic water a year per unit. That's a lot of extra water. So as you go through, this is my contact information. As I said, Angela is going to send this out to everybody. If you have any questions whatsoever, I certainly would tell you that I'm not an expert at this, but it's certainly something that I've spent the last couple of decades of my life working around, and we would be glad to help you. Only understanding from, you know, like we do at SMA, from educating, but structurally, what can we do to get you involved and get the people you know involved? Rainwater is, well, water in general is the oldest utility in the world, like we talked about. But it's also the most misused. So just think about that less than 2% of the Earth's surface is natural domestic drinking water. And that number is going to dwindle down as population and densification continues to happen, especially in urban America. So rainwater is not something that's impractical. It's very inexpensive to do. It's very easy to maintain. It can be used for pets, gardening, lawn, laundry, toilet flushing. And like I said, if it needs to come down, we'll soon see some practicality come down by federal law here in the United States, where there will be some drinking water standards around use of rainwater. So if you use the ideas that we kind of went through today, you'll have a great opportunity and you're going to help us lower the global ecological footprint of the way water is used. Angela, I'll turn it back over to you.
Thank you so much, Rex. That was such a great presentation. Actually, I'm going to make you the presenter again so we can look at your slide for your contact information on the end there. I apologize. Hang on one second. Made a boo-boo there. Okay, so making you the presenter again, Rex, and thank you so much for so much information. That was actually a lot of information as we went over the multiple uses of rainwater and catchment systems. And personally, you know, I think everyone on this call is interested for a different reason, and I really appreciate that you went through so many applications. And when I think about the commercial space, though, even manufacturing to clean their machinery and things like that, you know, to add in whatever they need to do for chemicals to clean out their manufacturing lines, or, you know, the car dealers to wash their cars, and the firefighters to have potable water to use in rural areas. And I particularly was interested in a lot of the information that you had provided about how communities are really managing to first use the stormwater before they send it into wastewater treatment. You know, here in our local area, our stormwater is sent to wastewater and then flushed out into the Sacramento River and then flushed out into the San Francisco Bay, and it's never used. And we spend a lot of money to clean it and then send it into the river to flush it out into the ocean. And so, you know, as you said, there's a lot of ways that we waste that water. When it's really precious, we could use that 2% instead of flushing it out to be able to water some of our irrigation for our cities and communities and counties. And definitely in the state offices, you know, I know ours was probably the only green grass in the state of California throughout our drought years, you know, because they want to keep the capital beautiful, of course, you know. So those are some really clever ways I hadn't really thought about. And I know I have to be honest with all of our callers on the line today. I am completely biased about rainwater and catchment because I was introduced to it by my landlord in Belgium when I was an international banker there. And I had two 10,000-gallon tanks under the ground that she asked me if it would be okay if we use that for indoor toilet flushing. And I thought that was really interesting. And so we used it for all of our irrigation as well. And so thank you, Rex, for informing us about the regulations that the EU has put into place to be able to really utilize this very precious resource. So I know you have a few questions from the callers today, a lot of them centered about the automatic pumping systems and the UV lighting, to think about how much electricity would that normally cost a user. And if some of our question holders could please chime in, were you thinking about residential or commercial usage? So Rex might be able to answer those questions a little bit more precisely. And at this time, please feel free to just unmute yourself and just chime in.
Well, I think overall, Angela, again, when you look at usage for utilities, pumping stations today and UV stations today are very practical users of electricity, especially UV. Pumping stations in UV, again, they're only really predicated on using electrical when it's a demand situation. It's so if a pump station is built in practically and it has a pressure tank in it, for instance, it'll keep constant pressure. So if it doesn't need to turn on, it just won't turn on. Same thing with the UV, but in generality, when you talk about a UV bulb in a house, you may be talking about $50 or $60 for the year to run one, maybe, for a house. They're very inexpensive and low users of electricity.
Right, I just use gravity for mine. I don't even use a pump system for my irrigation tanks, and I just use that for my own garden. So I think that what I was thinking about for my own application is for the firefighters to be able to hook up to one of these tanks that might be around the different areas of the property. And would I need a pump for them to be able to drain the water? As long as it's gravity fed, would it be sufficient?
So it depends on the installation, the way it's done, but typically when we have clients that have larger rain tanks, especially commercial and industrial clients, we always suggest to them that we would put the external flange onto the tank, so the local fire department could hook onto the tank. And what generally speaking is we can get the fire department typically out on an installation to look at it, and it's just unprecedented the amount of positive feedback you get. Generally speaking, on a pumping station, it actually pulls water to the truck, so it has its own internal pump. So it's not necessarily a necessity to have one, nor would you want one, because they do it at a different velocity, GPM, gallons per minute, than most pumps pump for regular usage.
Okay, thank you.
I had another question too on the chat that someone asked about bladders. Do I always have to have a bladder for walleye quality? The answer is no. The answer would always be is whatever kind of containment vessel you have depends on whether you use a bladder or not. So some FRP tanks use a film on the inside that's almost like a paintable bladder. It's not an option. It comes with it because of the way that you're going to use the water. And the tank that you see here under my contact information, that tank comes in two different ways. The tank that's pictured here is actually galvanized steel, and it actually is sealed with mastic and epoxy. So the inside of it does not have a bladder. A tank that we can get you that looks exactly like this, however, would cost several thousands of dollars less, would have a bladder. And people always ask, well, why would you use one versus another? The specifier, the architect, and the engineer specifies what kind of tank someone would you want to use for whatever application, and that's the reason why there's a difference in the tanks. Generally speaking, a bladdered tank costs less.
Interesting. And then for this type of tank there, what is the size of that tank in your picture?
That tank is almost 80,000 gallons.
Wow. Why don't our water companies have those?
Well, the real reason is because we have the most overabundant water source on the planet in the United States. That's the real reason. And the municipalities and the water infrastructure was built out decades ago, and it is a big business. There's trillions of gallons of water sold every second of the day in the United States.
Right. The liquid gold, a lot of people call it. I had a question here from Madison, who asked, how often do tanks have cracking or leaks?
I would tell you not very often, as long as they're not hit with something. They don't stand up very well when people run into them with things like cars. As far as the tank, like you see in the picture, that tank should sit there virtually maintenance-free for at least 30 years, at least. Now, is it maintenance every year? Yes. There's usually a factory authorized, certified person that goes out and looks at the water tank every year. They look at everything on there to make sure that there's any shifting in the foundation, something could have happened, make sure the piping that's going in there is adequate still, making sure that anything that could have been shifted over time changes. For instance, in your part of the country, they have to be seismographically engaged and engineered.
Right.
It's the way it has to be done. On some parts of the country, they don't. But generally speaking, an FRP tank, when you put it in the ground, it's usually there for about 20 years, undetected. Sometimes longer. The new technology would keep an FRP tank even longer today, but most manufacturers warranty it for about 20 years.
Excellent.
In most cases like these with the liners typically will last as long, if not longer, than the tank.
I wonder if any of our callers might be interested in, at least at home, to start collecting your rainwater and have any questions about how to get started and hooking that up to your gutter system, because that's how you very quickly fill up your tank, is just hooking this up to several of your gutters, and you could really fill a 2,500 gallon tank in one day, in one rainstorm, with an inch of rain. So,
Yeah.
and anyone interested in talking about that?
Yeah, Kevin had a interesting question, and he asked about, can we explain some of the economics and business cases for organizations to implement rainwater harvesting? I could pretty much start from a plethora of companies, including the largest water user in the world, which is Coca-Cola. So in the United States, Coca-Cola currently does not make Coca-Cola with rainwater. However, they do in Brazil. So it isn't that it doesn't get done, it just doesn't get done everywhere. But for instance, Coca-Cola, the business case for them, what do they use most of their rainwater systems for? Well, twofold. The number one value proposition or value added that Coke does is do something like we're currently doing with them as a company, where we're actually installing a rainwater system on an actual park playground area for communal gardens, and Coca-Cola is funding it 100%. That's a huge engagement. As a corporation, they use it for wash down. So parking lot washing, building washing, they use it in their coolant towers. The number one rainwater harvesting in the country, today I would tell you it's still the number one in the world by a landslide also, which is the Home Depot. They use rainwater to actually irrigate their plants that you buy as an actual customer. So the economics for them is in 2016, they saved almost 80 million gallons of domestic water that never went down the storm drains, and it was used directly on their own plants. So it lowered the price of goods sold and lowered their total operating utility expenses simultaneously. But when you get to some others, when you look at rainwater harvesting, I think from an economic standpoint, you could look at some very clear situations. Laundromats that use rainwater instead of domestic water, car washes, which we do a lot of. We do huge businesses with car washes. There's a big value added to irrigation, especially for small, urban, organic, hydroponic farming today and aquaponic farming. Love rainwater. I mean, there's such a plethora of people that use it. And like you said, we're in Belgium. You really didn't know that you had it until someone said, hey, can I do this? Today, you're seeing more and more of these. Why? Because people have them. A perfect opportunity is we have a lot of projects that go year to year through major colleges and universities. They use rainwater harvesting to do a lot of the irrigation on the properties. They do a lot of it for toilet flushing on their properties, and it keeps it from stormwater management, and they're just becoming good stewards of the environment.
Definitely. I'm very excited about that because, you know, I think most of us on this call are stewards of the environment, and we're trying to do the low-hanging fruit, you know, and rainwater and catchment is low-hanging fruit to me, and I'm really glad that you have made your business model on being able to help people around the world to have fresh water solutions. And you know, the work that you're doing is so important. All of you on this call today from this industry, I really thank you for giving this the opportunity to think about ways that we use water where we don't really need fresh potable water, where we could absolutely reuse the rain. And so I really thank you for all that you're doing. Does anybody have any last questions or comments? I see one coming in from John. Thank you, John. Talking about how do you use rainwater at home, especially Central Florida, you have very problematic freshwater areas as well in Central Florida. And so when I'm using my rainwater at home, it depends what you have. I wash my dog with my rainwater. I use it for my compost. I use it for all of my houseplants and for my garden. And I use it to water the grass if I have a small piece of grass that I like to mow. And and then when it runs out, usually in July, I'm very sad. And so that's why when Rex said, usually if you save it, you wish you had more. And that's what absolutely I agree with, that you can never actually harvest enough rainwater because it just doesn't go bad. And you don't have to worry about treating it or anything like that. And like Rex said, you can hook it up to your own plumbing system and to use it for your gray water in the house for toilet washing and using it in the laundry. And I think I may definitely contact you, Rex, to experiment with that as well, maybe using it in my laundry machine. So that's exciting. I never thought of that.
Yeah, absolutely. So, John, the rest of your question, I think, too, like Angela just gave some really great examples of it. So it's really dependent on irrigation, whether you're using an irrigation controller system versus a drip irrigation system. So drip irrigation, a lot of people use the rain barrels I showed you. And by the way, that's 4 out of like 48 different varieties that we manufacture. So what's kind of cool about them is those rain barrels, just like the rain filters and stuff that you can get through climateincorp.com, all of those products are sold through a vast network of dealers. One of our dealers is on the call today that does a great job of rainwater harvesting in Texas. But when you look at that type of a scenario, drip irrigation is done a lot off of rain barrels also, because you can put them on downspouts. They're very low in servicing and they're very high in yield. The biggest thing that, again, we laugh about at the office all the time when people go, well, this rain barrel looks big. I'm like, well, I'm kind of big and I can stand inside of it. And they go, see what I'm saying? I go, it won't be big after your first half inch of rain because it'll be overfilled. And then you're going to really want to know why you didn't have another one. So they're really easy to connect, but you can use them for drip irrigation. You can just stick a hose right on the bottom of it and just put a drip irrigation hose on there and turn it on and let it fly. Like Angela said, it's sad when you're a harvester the day that you don't have any water, though. Like for me, I use one even on my own home. I've had it for about 15 years, and it actually runs an entire water feature that the waterfall in my yard is almost 39 feet long. And it's run and powered by rainwater. So it's really cool to be able to use it all the time for irrigation, gardening, especially house plants and vegetables that you grow love rainwater because it's virtually chemical free. Like I said before, not only is the good Lord went down and purified it and filtered it, but by the time you go through a pre-filtration process, it's as clean as you ever want to be able to drink, I can assure you. Because I'm one of those people that love to drink rainwater. As a matter of fact, there's a couple of companies in the United States that now have licensing to bottle rainwater. And you can find that as well on climateincorp.com.
I saw that. And also, Michael, another thing is if you have gutters on your house, or John, I'm sorry, if you have gutters on your house, those are the key areas where you could put a rain barrel right underneath one of those. I like to put a pipe actually to my rainwater tank. This way I can have a 2,500 gallon tank, and then so this way I don't have to worry about overfilling it too rapidly. And so there's a lot of ways that you can do this, and definitely reach out to Rex after the call. And for the rest of our callers, I'm so sorry we've run out of time for today, and I really thank our guest speaker, Rex Hayes. Thank you so much for being our presenter today. I really truly learned a lot, and I hope all of our audience did as well. And thank you all for joining the call, and I wish you a very good day.
Thank you. How many people are on?